Hey everybody, thanks for tuning in to watch this little video on special right triangles. I wanted to explain where we get them, what they are, and what the shortcut is for those things, because it's a super useful thing for you as a math student going forward. You're going to do problems from this point in your math career on, and many times you'll run into this situation where you need to know some information about a certain kind of triangle. And these two right triangles have a lot to do with quite a bit of more math. So it's a really useful shortcut to know. The two special right triangles that we're talking about are the 45-45-90 right triangle, sometimes called an isosceles right triangle, and the 30-60-90s right triangle. Now, the 45-45-90, we get that from dividing a square in half. You have to take a square, you draw one diagonal. You've just made a right triangle where two sides are the same, therefore it's an isosceles right triangle. And the angles, by dividing those 90-degree corners of the square in half, you get 45, 45, and you would still have the 90-degree corner here. So this is that 45-45 right triangle. In a similar way, if you take an equilateral triangle and divide it in half, all right down from the vertex right down to the base, you make a right angle here. You've made two congruent right triangles, and the 60-degree angle in the original triangle is still there, but this angle up here has been cut in half. So it was 60 degrees for the whole triangle. When we cut it in half, it's now 30 degrees. So we have a 30, 60, and then 90 degrees down here in this corner. So that's where this triangle comes from, is by dividing an equilateral triangle in half. And so because of that beginning for each of these triangles, it gives us some properties kind of embedded right into the triangle. For example, on the isosceles or the 45-45 right triangle, if you know the length of one of the legs, you automatically know the length of the other leg. They're the same. It's an isosceles right triangle. So this leg's length is always equal to that leg's length. Okay, so that's something that you get automatically if you know that it's an isosceles or a 45-45 right triangle. Now, if you are looking for a way to express the hypotenuse, all right, of that right triangle, you could use the Pythagorean theorem. So I've got it kind of worked out here. Leg squared plus leg squared equals hypotenuse squared, right? That's the Pythagorean theorem. So in our case here, x squared plus x squared equals, and I'm calling it c for now. When I add x squared and x squared, I get 2x squared, and that equals c squared. So I want to get c by itself. I'm looking for this side here, and so I take the square root of both sides. When you take the square root of 2x squared, all right, you could think of that as the square root of 2 times the square root of x squared, because they're multiplying together. So you can break up this radical into two radicals multiplied together. Well, the square root of x squared is just x. So x squared, this radical right here becomes just x, and you have x times the square root of 2 equals c. This is our shortcut now. Our hypotenuse is now in the same terms as the leg, sorry, right here. So that's x, this is now x root 2, all right? So for example, if that x was a 3, well, this side would also be a 3, and this hypotenuse would be 3 root 2, 3 root 2. All right, so there's our shortcut for the isosceles or the 45-45 right triangle, x root 2. Going back up here to the beginning of our, for the 30-60-90 right triangle, if you do the same kind of thing, this short leg here, if you think about where it comes from as half of this equilateral triangle, means that this side here is only half as long as that side. So that's the hypotenuse now of our 30-60-90 right triangle, and it's twice as long as this side right here. So if this is x, this is 2x. All right? So once again, if I have x and 2x for the hypotenuse on this right triangle, I can set up the Pythagorean theorem. I'm calling this vertical side here b for a second. And when I work out the Pythagorean theorem for this triangle now, x, 2x, b here, x squared plus b squared equals 2x squared. There you go. There's your setup for the Pythagorean theorem. 2x squared, actually, when you work that out, you get 4 times x squared. And this is x squared here. I'm trying to get b all by itself so I can have a way to write b in terms of x. I subtract x squared from both sides. 4x squared minus 1x squared is 3x squared. So I've got b squared equals 3x squared. And when I take the square root of both sides to get b alone, by doing that same kind of little thing that we did over here with the x and the x squared and the root 2, this is going to be x times the square root of 3. So now my shortcut for the 30, 60, 90 right triangle is x, 2x, x root 3. All right? So the legs are x and x root 3, and the hypotenuse is 2 times the short leg. All right? Let's do a couple of examples. So here's the 30, 60, 90 to begin with. If that side is a 4, that's the short leg of our 30, 60, 90 right triangle. If this side is 4, the hypotenuse is 2 times that, so that'll be 8. And the long leg is this number times root 3. So this will just be 4 times the square root of 3, like that. And that's all you got to do. You don't have to get a calculator out and figure out what this is. You can just leave your answer just like that. That's perfectly exact way to write that length. 4 here, 4 root 3. Okay? Over here in this one, we have the long leg given to us as 14 root 3. All right? So we know that this side here, this short leg times root 3 gives us that. And if that is 14 root 3, then this side must be 14. Then the hypotenuse is twice as long as the short leg, so 2 times 14 is 28. Okay? So here's another example. This one's a little bit harder. This side, the long leg is 18. All right? We need to know what the short leg is and the hypotenuse. Well, we've said before that the short leg, whatever that is, times root 3 gives me this long leg. All right, that's my shortcut. The short leg times root 3 is the long leg. That means that 18 is some number times the square root of 3. All right, so for our purposes right now, all you need to do to solve this equation for x is divide both sides by square root of 3, just like you would for any other number, and the other side is just 18 divided by the square root of 3. That's x. So this is 18 divided by the square root of 3. All right? This side here is just 18. So that's what we started with. We didn't change that, but we wrote a little equation and solved it for x, which I'm calling this side right here. X equals 18 divided by the square root of 3. Later on, I'll show you a trick for writing this fraction in a little bit different way. But right now, this is good enough, and the hypotenuse is always 2 times that. So what's 2 times 18? Well, you can think of 2 as 2 over 1 times 18 over the square root of 3. So 2 times 18 is 36, and 1 times root 3 is just root 3. So this is now 36. Let me write it a different way. It's 36 over square root of 3. And that's the length of the hypotenuse. Okay? So that was a little bit harder one to deal with numbers when you get a integer for the long leg, because that number is supposed to be something times the square root of 3. So you got to divide it by the square root of 3 to find that short leg. All right? Let's take a look at a 45 right triangle here. A couple of examples. If we have the, here, let me get it there. So if we got the hypotenuse equals 9 root 2, all right, that you know that this number down here times root 2 gives you this, okay? Gives you the hypotenuse. So if this is 9 times the square root of 2, well, this must be 9. And since it's an isosceles right triangle, this is also 9. So 9 root 2, okay? This one over here, we've got the hypotenuse given as a nice friendly integer, okay? And if we call these two sides here x, and we know they're both the same, so once we find one, we will be able to find both of them. But we know that this number times root 2 gives me the hypotenuse. That's my shortcut for the isosceles right triangle. Leg times root 2 equals the hypotenuse. So I'm going to write it off to the side here this time, rather than up on the triangle like I did there. So x times the square root of 2 equals 10. Well, it's no different really than what we did up there. We're just going to divide both sides of our equation by the square root of 2. All right? And the square root 2's cancel out. And so you have this side here is just equal to 10 divided by the square root of 2. And that's what we can write. We can write this as 10 divided by the square root of 2. And over here, same thing. It's an isosceles right triangle, so both legs are the same. 10 divided by the square root of 2. Okay? So in another video, I'll show you kind of a math trick that people like to use for fractions where there is a square root on the bottom of the fraction. There's a special way that people like to write that. All right, well, sounds like the siren's coming. I better finish up this video. So have a good day, everybody. Bye-bye.